Okay, the last operation we're going to look at is taking a root. And let's make this first one a little bit easier. Let's go find the square roots, or the 2 roots of z. Or in other words, like I said, we're trying to take the square root of that. So if you take a look at the formula here, you can kind of relate it to demoivres. Remember demoivres, you were raising it to a power. If you think of that, that means I am raising this, the square root means I'm raising it to the 1/2 power. So I'm going to take the square root of 16, which is 4. I'm taking cosine and I'm taking 1/2 and I'm multiplying it by 1. This is pi over 2 times 1/2. You get pi over 4 plus I sine of pi over 4. But if we're taking the square root, that means there's a second root in there that we need to find. Now first, let's just confirm that this one actually works. Remember what we're saying is if I take this and I raise it to the second power, I should get back to what you started with. Well, now you're using demoivres. 4 to the second gives you 16. Pi over 4 times 2 will give you pi over 2. And again, pi over 4 times 2 will give you pi over 2. Now the question is, how do we find that other root? And it's kind of hidden inside here. I'm going to make it a little bit easier. I'm going to take, if you think about 2 pi k, that means that's equivalent to 360. So I'm going to take 360, and again, I'm going to multiply it by 1/2, and I get 180 degrees. So that means I need to travel 180 degrees to get to that other root. In other words, I still have the same magnitude. I've got cosine. If you think about pi over 4, I'm here and I need to go 180 degrees. So 1/4, let's try again, 1/4, 2/4, 3/4, 4/4 should put me at 5 pi over 4. Plus again, same thing of sine 5 pi over 4. Now, if that's confusing, if we need to, we could go change it to degrees. So let's go and do that. This would be cosine of 45 degrees plus I sine of 45 degrees. If you add on 180, that gives me 225 degrees. So again, what we're saying is if I take this and I raise it to the second power, it should be equivalent to what we started with. Well, again, 4 squared is equal to 16. If you take 225 and you multiply it by 2, so 225 multiplied by 2 is 450 degrees. Let me see if I can get that glare out of the way for you guys. There we go. So I'm going to take 450 minus 360 because that's once around the unit circle, and notice you're at 90 degrees, which is equivalent to pi over 2. All right, let's go take a look at another one. We're asked to find the 4th root, or the 4th roots of 16. Now, many of you might already think, well, I know 2 of them, it's plus or minus 2. That's correct, but there are still 2 more in there. So we're going to use this theorem to prove these 2 exist and then go find those other 2. First thing I'm going to do is go ahead and rewrite this in complex form. That would be 16 plus 0i. I'm going to go change it to polar form. So again, let's go find the magnitude. 16 squared plus 0 squared. We end up with a magnitude of 16, and then we want to go and find theta. So again, theta is equal to the inverse of 0 divided by 16, which is the inverse of 0. So when is the tangent equal to 0? That's at 0 or 2 pi. So let's just write it as a 0 pi. All right, so we've got 16 cosine of 0 pi plus I sine of pi, 0 pi. And we want to find the 4th root. So again, that means we're going to take the 4th root of this, and then we're taking each one of these and multiplying it by 1/4 or dividing it by 4, whichever is easier. I think I'll stick with multiplying by 1/4. Okay, so our first fourth root, the square root of 16 is 2. Let's think about this. This becomes cosine of, well, 0 times 1/4 is going to be 0 pi. Same thing over here, that would be 0 pi. So let's simplify that up. Cosine of 0 pi is 1. The sine of 0 pi is 0, and we end up with 2, which is one of the roots that we already knew existed. Now we got to go on to the second one. So think about, how did we get those next roots? We took 360 and we divided it by the number of roots which we were looking for, which in this case is 4. So that means I would travel 90 degrees adding on to the 0 pi to get to my next root. So we would have 0 cosine, and let's go ahead and change it to degrees to make it easier. That would be 90 degrees plus I sine of 90 degrees. Cosine of 90 degrees is 0. Sine of 90 degrees is 1. Take a look at what you have. You've got 2I for your next root. Probably not one that you would come up on your own, but we could verify that it actually checks out. Remember, what we're saying is 2I to the 4th should get me back to 16. Well, let's take a look. 2 to the 4th would be equal to 16, and I to the 4th, if you think about that, breaks down to I squared and I squared, which is -1 times -1. Those cancel out, and you are left with 16. Let's go on to the next root. So again, same magnitude, but again, we're traveling another 90 degrees from here, so that would put me at 180. So we've got cosine of 180 plus I sine of 180. So think about 180 degrees is here. My cosine is -1. My sine is 0. This simplifies to -2, which I already knew on my own. Again, taking -2 to the 4th power gets me back to 16. Now you might be able to guess what the last root is. You've got 2, -2. We had 2I, so probably your guess is going to be a -2I. Let's go ahead and verify it. Again, you've got 2 cosine. You're going to travel another 90 degrees. That puts me at 270 plus I sine of 270. So think about 270. It is here. My cosine is 0. My sine is -1. Notice you end up with -2 as your final root of that original number. Again, we can check it out. We're saying that -2I to the 4th should get me back to 16. Well, -2 to the 4th again gives me 16. I to the 4th is the same thing that I did here, and again I end up with 16. So my final roots are 2, -2, a 2I, and a -2I. I would say this is probably the most difficult. Look it over. We can certainly get on and go through some more if you need that as well.